So hi everyone. The goals of this talk is much more to see how we can use NLP's techniques to resolve some African problems. To start, so I'm Isaac Imgeng. I'm senior data scientist. I'm working in advertise a tech startup named Blink. I'm also trainer, a mentor in open classroom. And for others, I'm like to share my knowledge on Medium also. And when we talk about NLPs, we have to talk about different things. NLPs, like others says, is a subdomain of machine learning and AI. And in NLPs also, we have subdomains. So we have NLU for natural language understanding, or NLL for generation. And the goals of NLPs is samples is to try to transform the text data into numerical form of data in order to use these data on traditional machine learning algorithm like random forest and others. And how we can transform this data. We have many ways to do it. And I think the other speakers have show a little bit different way we can use to transform this data. But you also have to try to understand in the logical form how you can do it. So here you can see a way to do it is just to use all the token, all the words in the ensemble of text and try to say, okay, I like these articles, which words match or not matching. And for that, once you have done this step, you have transformed these three sentences to a matrix representing the vector of representing each of the sentences. And when you have this vector, you have the numeric data, you can use these vectors to try to plot and see the difference or the similarity between the words. So here you can see a visualization obtained after some transformation. And you can see that computer and Android can be close together, and our computer and UO are very different. In that difference come from the way we transform the data to numeric. So there's a lot of techniques used to transform this data. You can use TF-EDF like others says, Word2Vec, Glob, and the last one, and Perform one, I think, BERT. But here, the way I want to think is not so just using the techniques, but try to know in which case, which business case you can use one technique on others. Now you can see that for perhaps translation, we have to understand the link between the first and the last words in the phrase to better transform it. So it is perhaps better to switch to birds. And for others, we can use a TF-EDF. For example, when you try to extract data from logs and Word2Vec also. So I just want to share you is this good for me or not? Share some representation of what it looks. So this is a representation, a text vectorization representation obtained when we use a Word2Vec embedding with all Wikipedia knowledge data. So perhaps if you tap here PHP, we can show that for these words, we have some other words like GSP, like, I don't know, PowerShell. And for when you see that, you understand that the transformation of the words from Wikipedia using this technique help us to find the right representation to embed the sense behind each words. So in terms of use cases, NLPs have many use cases. I don't have to talk about all a little bit, but I think now, because we have a lot of media, a lot of social network, and in all of the social network we use to exchange, we use text. So we have a lot of text today, and NLP is really important in this case. For the demo, the way the use case I want to share you is just to try to fix a traditional problem in Cameroon or in Africa globally about how we can find the right job for us. In Africa, you see that many students after school don't have a lot of knowledge that the company needs. And the company perspective, they saw that he have the really the break about what he found and what he can find in the job area. So to fix that, we have to try to find a way to understand what a people, a student knows about his resume, and what the companies needs about his description job, and try to match it in order to help people to say, hey, to get this job, you can you could learn a new technique, like you could learn SQL, you could learn data engineering to fit more job in your job area. For these use cases, the way to achieve is to extract from result, but from description also, metadata. To achieve this, we can split the use case in two sub cases. The first one is NER, name entity recognition, and the goals of this NLP technique is to extract keywords, most important keywords, from a text. And you can also use a classification algorithm to try to say this resume is about medical or is about engineering. And when we have extract all this information from a result or from a description job, we can now match it with the others description from the database and present the most relevant one to the candidate. So let us just share how we can achieve it. Okay, how can I close this thing down? Okay. For this use case, I've used a Kaggle dataset from monster.com, and for the use case also, I've made the choice to use fast text embedding. Fast text embedding is a Facebook technology for embedding, and the goals or the intention behind fast text is just not to try to make engrams, so not to find the couples of words, but try to find the sub words inside the words. This technique is so interesting in case, for example, where you have a misspelling in your data set. So the algorithm can also detect it and correct it very efficiently. So for that, we import some standard stop words and library like NLTK and Spacey. We try to build a processing step. This processing step is much more for clean, to make a cleaning step before apply the model. So we have to remove bad things, bad slashes and spaces, for example. And after that, we can see that for this data set, you have here the job description and the corresponding category. And here we can see that we have the count of each category. And a point here you can see experiences is more represented than the others. That is a point when you make a machine learning task, you have to take care about, because you have here an unbalanced data set, and that can make poor result at the end. So here you can apply to our text a cleaning process. The cleaning one we have defined, and after that we embed the text using fast text. And this process gives us a model, fastest model. And what you can see here is that this model transforms each word in our corpus in a vector with 300 dimensions. So each word is transformed to this type of vector. And you can see here the vector representation of PHP, for example. So using this representation, like you have seen before, you can find the most similar words based on this vector representation of this word, PHP, for example. And you can see that the model have captured the sense behind the words and try to predict us most relevant words like Java, Python, JavaScript. That is really great for this type of algorithm. But we can also notice that the score, the probability score is so poor. It's just because of the size of the data set, which is really small for these cases. You can also see here the negative, most similar words from PHP. And this, using this vector representation, we can make a plot to see for the word PHP where we can find the other words around. And you can see that this vector representation, after plotting represented, show us all the relevant words in the same context of PHP. That is really interesting. So after this word embedding, to achieve the task of classification, we have different techniques to achieve this task. You have choose the latest or the lowest one, I think. And this approach is to transform our vector in a standard data frame or spreadsheet data, where each line here represents a dimension and the target is the standard one. And to get this vector representation, we choose to create it by taking the mean of the representation of each words in a description. So if a description has 10 words, we compute first the vectorization of each word and taking the mean of this representation. For instance, it's not the really good approach, but it helps us to obtain a traditional data frame where we have all the dimension and the target value. And once you have that, you have just made here a type of equilibration of the data set to try to reduce the difference between numbers of individuals each case to obtain a more equilibrated data set. And for modelization, we have used a random forest and try to make some hyperparameters to obtain like you see 0.16 accuracy. That's not really good for this type of algorithm, but we have to take account about the size of the original data set to evaluate this curve. So when we have this, we can test our algorithm by using by putting different text description of job and try to see how the model can find the right category and which probability they assign for each category they found. The goals here is to try to see if the model really learn each relation between words in each different category and apply the good response. And for that, we can see that for this use case, even if you have produced business for this description, the probability is so poor. And once you have this algorithm or this process done, you can embed this algorithm using, for example, an API service like Flask and others to create a microservice and connect your algorithm to a web page in order to try to make a request. When a user try to make a request to your service, this API will predict the right category and push it and try to fill this gap between the resume keywords and category and the all others job categories you have in our databases. And for that, we are building this web app, if I can say it like that. And we are still using this type of categories to try to build this platform AI jobs to help people first to try to find the right job during her resume, but also try to find the job in other countries than her countries. No. So we have to embed also data from Nigeria, from Kenya, and others to help people to do this. I think it's all from me. I don't know if you have a question or not. And here you can find resources if you want to start in NLP, your NLP journey.